Hi guys, welcome to another episode of MrLopezClasses.com. This is the chapter 11 of our marine electronic book, and we are going to cover the topic related with the coaxial cables. We are going to learn the specification about the coaxial cables, what type of coaxial cables are recommended in each specific situations, where should be installed those cables, what type of connectors we are going to use, and we are going to check some recommendations from the National Marine Electronics Association in relation with the coaxial cables. Yes, we need install coaxial cable depending of the equipment, like I explained before, for TV, for audio, for stereo, some satellite TV. They use specific antenna cables. And we are going to follow a specific recommendation for each type of cable. We are going to check quickly the definition about the coaxial cable and what is the meaning of each topic. The coaxial cable is an element designed to transfer radio frequencies to antennas with a minimum loss as possible. Data loss depend on what? Depend on the insulation of the cable, depend on the conductor, the center conductor of the cable, depend on the radio magnetic interference around the area, and depend also about the type of connectors used and how the connectors are installed. If the connectors are soldering or only crimped, it's different. Soldering is better. Soldering is better in general. The coaxial cable is a type of cable that has an inner conductor surrounded by a tubular layer and surrounded by a conducting shield. This is the shield. This is the insulation. Normally, it's a plastic, and this is the center conductor. The center conductor is in two shapes, solid or stranded. Normally, in marine application, it's recommended stranded because we need more flexibility. Exactly the same like in our previous book with the marine cables. The marine cables are different like the industrial cable. The industrial cables are solid. Our cables are stranded basically for flexibility. Exactly the same with the coaxial cables. In my opinion, the solid cables, the solid conductors, the coaxial cable with solid conductor have a better performance and a little better efficiency. Okay, applications. Application of the coaxial cables. In general, the coaxial cables are used in order to transmit radio frequency signals. Its application include feedlines connecting radio transmitters and receivers with their antennas. They are used also in computer networks like internet, and also they are used for distribution of TV cable. All right, this is a slide that I want to share with you. That slide is coming from the National Marine Electronics Association. It's part of the training presentation in order to take the certification for installers. This is a summary about the explanation, the fundamentals of the coaxial cables. The coaxial cables, once again, are used to transmit radio frequency signals. In a coaxial cables, we talk about impedance, no resistance, but the unit is the same. The unit of the impedance is in ohms, and exactly the same like the resistance in electrical cables. But the impedance cannot be measured with a typical multimeter. We need a special equipment that we are going to talk later in order to read impedance. Okay. Other common term that we are going to use is decibels. Decibels is the measure of the gain or loss related to the radio frequency. Decibels, that's the measure of the gain. You remember we talked about the gain in different chapters, and right now we are going to talk again about the gain. Okay, in relation with the impedance, we talk about the impedance. Those are the most common impedance in marine coaxial cables. We are going to use 75 ohms and 50 ohms. Both of them are commonly used in marine application. And depending on where is the cable and what is the function of the cable, we are going to use 75 or 50 ohms. I'm going to explain later with a particular example. And that depends on the function of the cable and where should be located that cable. And this is the nomenclature. The nomenclature used for the antenna cables. This is the meaning of each letter. Okay, the letter R is because the radio frequency. The letter G is because it's for a government. The number 8 in this particular case is a specific number assigned for the government. And after the slash, we have different letters, and this is for universal specification. Okay. All right, and this is basically the construction of the cable. We have the jacket here. This is the brain, the shield. The shield is very important. The shield is, if this is the cable, this is the shield. This is the isolator, this is the conductor, and this is the jacket. The shield is very important because I am going to explain later. We are going to bend that shield in order to introduce the connector here, and that shield will be the ground. Of the connector. If the shield is not properly bended, the connector doesn't have ground. Immediately the connector is introduced here. You can solder in through those holes. The shield, and additionally you can solder in the conductor at the end, like the picture that you have on the screen. This is critical, and once again, that shield will be the ground of your connector because you bend it here, and after that you introduce the connector like the picture that you have on the screen right now. All right, this is important. Once again, the conductor could be solid or stranded. And those are the most common impedance, 50 ohms and 75 ohms. But let me share this table. This table is better. In this table for 50 ohms, the majority of the coaxial cable for marine applications are in 50 ohms. And those are the most common cables that we are going to use, the coaxial cables. Those are the most common cables used in marine application, all of those. And this is the external diameter, outside diameter, the first row. The second row is related with the gauge of the wire, And the third row is related with the impedance. The majority of our cables are in 50 ohms. And this is the typical loss per each 100 feet. The loss of the antenna cables are measured in decibels per each 100 feet. And in this particular case, per cable RG50A, the loss is 5 decibels. 4 decibels for RGAX, 2.6 decibels for RGA, 2.6 decibels for RG213, and 3.1 decibels for LMR240. And those are okay. The first one is for frequencies around 160 megahertz. For frequency around 900 megahertz, those are the loss. And for frequency around 1900 megahertz, those are the loss. Okay, this is a good table. I recommend that you try to make a picture of this table because that table will be useful for use in the future. Okay, in this slide, we have the most common coaxial cables used in marine applications. Those are the same cable that we have in the previous tables. One of the most common cables is the RG50A and the RG59, 50AX and 59U. Those cables, this one in particular, RG59U, is available with either solid copper or copper clad steel center conductor. It is suitable for basic analog TV antenna fit in residential application and for basic CCTV in antenna in marine applications and residential applications also. Okay, we are going to continue with this table. This table is excellent in order to understand the most common coaxial cables and where are used. For example, for analog TV, we can use both cables, RG59 and RGA. And for CCTV, we can use those 4 cables. Yeah, and for satellite TV, those are the most common cables for satellite TV. This is for CCTV, and this is for analog TV. All right, and those are the specifications in total length. This one is excellent for lengths less than 225 meters, and those are excellent for distance in between 220 and 425, and exactly the same with the rest of the cables. This column is related with the total length of the cable, and this column is related where should be used for analog TV, for CCTV, or for satellite TV. Okay, and this is another slide coming from the National Marine Electronics Association. This is wonderful and is basically a complement of the previous one. But this one is more related with the type of connectors. Okay, I can use the same cable with different type of connectors. And the connector depend on what? The connector depend of what type of signal we are going to transfer, and depend on the manufacturer. Some manufacturers prefer some type of connectors because they consider that those connectors are better in order in terms of transmission. And those are the most common type of connectors: UHF, BNC, TNC, and F. All of those are the most common types of connectors, and those are the frequencies where each connector works, the frequency related and the impedance, and those are the most common uses per each cable. I recommend try to print this slide and try to memorize. I am going to send an email to you with this presentation, and you only need print the presentation. This is a good information related with the different type of connectors according with the application of each of these connectors. All right, for example, the BNC connector. The BNC, the name BNC is coming from a bayonet type connectors. They are commonly used in CCTV systems. Those connectors are specified in 50 Hz, the impedance 50 Hz or 75 Hz. But the most common in marine application is 50 Hz. This is the most common application for marine, 50 Hz. Okay. The other type of connectors is the F-type. F-type of connectors are used for CATV, SATV, and digital TV in conjunction with either RG6 or RG11 cable. Yeah, those type of connectors in general terms are used for TV transmission. The copper-clad steel inner conductor of the cable forms the inner pin of the conductor. Although twisted type of connectors are available, they do not produce a reliable connection in comparison to the crimped type connector that has been terminated in good quality. Let me explain what is the meaning of that. The first type, the twist-on type connectors, are the connectors that you have on the screen right now. And the second ones, the crimped connectors, are those connectors on the screen. The crimped connectors produce better quality in comparison with the twisted, the first one. The twisted is only with your hands, and they have too much interference. The crimped connectors, the quality is is superior, is better. All right, now we are going to talk about other important concept is how much can I bend it, my antenna cable? How much is the maximum radius that I can bend the coaxial cable without loss? Because you can bend it to the radius that you wanted, but you produce too much loss on the cable and too much loss on the signal and too much attenuation. In general terms, when you talk about loss, you talk about attenuation. In the next chapter, we are going to start to talk about the NEMA cables. And one of the concepts that are related commonly is the attenuation. Attenuation is loss. All right, coaxial band radius cables is the amount of radius that a cable can bend without any adverse effect. Bending, stretching, and kinks can force the center conductor to one side. This distortion the common axis of the conductor and the shield. They are no longer concentric and shows up as a change in impedance with too much losses. All right, this is the situation. You need avoid bended those cables over the limited recommended. This is another slide coming from NEMA. Is about the radius recommended, and those are the most important. This is the minimum radius recommended per this type of cables. This is the radius per this cable. This is the radius per this one. This is the radius per this one, and this one. I have exactly the same information in this table that you have in your book. This is the minimum radius. I want that you verify this and this, because I make an error in your book, please fix it this and this. This is the minimum bend radius. All right. And now we are going to talk about the frequencies, because the antenna cables have too much insulation, the jacket, the shield, the isolator, and finally the conductor. Why that excessive amount of protection? Is because those cables move frequencies, ultra frequencies, mega frequencies, millions of hertz. And let me show to you what is the meaning of that. You remember the most common type of antenna cables are VHF and UHF. VHF is very high frequency and UHF is ultra high frequency. Look at this. In VHF we have in between 30 millions of hertz and 300 millions of hertz. For that reason, the most common is 256 megahertz for very high frequency or VHF. Yeah, the majority of the VHF radios, marine radios, they work in 250 megahertz. This is a VHF radio. Okay, this is the band of VHF. Look at this. UHF is in between 300 millions of hertz and 3 gigas. And SHF is in between 3 gigas and 30 gigas. And EHF is in between 30 gigas and 300 gigas. Look at this. In the maximum amount of frequencies, the maximum in between 3 gigas and 300 gigas is located the microwave. The microwave. Can you imagine how much is the intensity when the microwave is operating with the door closed? Is in between 3 gigas and 300 gigahertz. It's a lot of frequency. With that frequency, the atoms, the molecules of water are evaporated and the food become hot. For that reason, the secret when you introduce food on the microwave is try to keep the food properly wet. If not, with the excessive amount of frequency, the small amount of water and humidity is evaporated, and when you open the door and you remove the food is completely dry. That's the reason. Yes, the microwave is a high, ultra high frequency equipment. This is one of the equipments with a higher consumption of energy in your home, the microwave. And the majority of the people think that they keep the equipments with higher consumption is only the water heater and the air condition. Yes, but the microwave also. Depending on the power of the microwave, the consumption is high consumption. You can check that one when you install the generators, and when you apply the load for air condition, you hear that the generator reduce the RPMs and recover immediately. You remember the gain? Exactly. And when you apply the breaker for the water heater, exactly the same. But when you apply the breaker for the microwave, with the microwave running, of course, the consumption in amps is excessive. This is one of the equipments with higher consumption in amps. Okay, this table is very nice. It's important that you keep in mind what is the frequency for VHF, for UHF, and what is the frequency where the microwave is running. It's a high, ultra high frequency. This is the spectrum of the frequencies. I want that you check this slide periodically. Okay, and that's for that reason the shield is an excellent shield with the thickness and the material in order to protect that excessive amount of frequency, right? Shield effect is the relative ability of the shield to screen out undesirable interference. In the case of the coaxial cable, the outer conductor provides a shield to keep interfering signals from getting in, the keep signal from leaking out to become undesirable interference for nearby devices. Those are the properties of the shield. Basically, the shield is to protect and drain. There are other shields here, and right now we are going to talk about the impedance. Basically, we have two types of impedance, 50 and 75 ohms. 50 ohms is primarily used in data, and 75 ohms is used in video applications. In general, the antenna cables for video, they work in 75 ohms of impedance, and the rest of the cables for the data are working in 50 ohms of impedance. The gain, this is an important term that we use in different ways in the electrical circuit and electronic circuit. A gain in electronics is the measure of the ability of a circuit to increase the power or amplitude of the signal from the input to the output. The unit for the gain is decibels. Yeah, you remember the gain in transistors? Basically, the unit to measure transistor is gain. How much is the gain of this transistor? Is 100, 500, 1000? That's the gain. And in generators, we use the gain. In antenna cables, exactly the same. Is in decibels. And what is the meaning of attenuation? Attenuation is basically loss of power. Attenuation is usually measured in decibels. Is in decibels per length. Okay, the attenuation increase when the frequency increase. Okay, the cables with higher frequency, they are propense for more attenuation. Type of lighting strikes. Once again, lighting protection. You remember? There are three types of strikes in antenna cables. Direct strike is a direct hit on a part of the boat, for example, the mast or the antenna. Conductive strike is a strike on a utility line or conducted aboard through the AC power line. An inductive strike is a nearby strike causing a large magnetic field, creating an extra voltage in the boat wiring by induction. Okay, we have three types of lightning strikes: direct strike, conductive strike, and inductive strike. You remember induction, conduction, and direct. Okay.
The coaxial cable loss. This is the more critical part of the coaxial cable. Depending of the coaxial cable selected and the coaxial cable connector, you have more loss or less loss. But in general terms, in order to minimize the loss of the cable, you should select the properly terminal, and you need to select the properly procedure to crimp it or soldering the terminal into the cable. The losses of cables, of connectors in the cable is 1 decibel per each 100 meters. The measure is in decibels per 100 meters. In the junction, in inline junctions, normally the loss is 0.5 decibels per each junction. Okay, the impedance are 50 or 75, and try to avoid excessive tight, excessive small radius, excessive bend on the cables, because you increase the loss. Okay, those are the most allowable cable loss, depending of the equipment. Here, for example, for marine VHF radio, normally is 3 decibels. For single sideband radios is 2 decibels. For cell phones, 3 decibels. In general, is in between 2 and 3 decibels, except for TV. TV is 6 decibels, is the higher. And those are the frequencies where each of those equipments operate. This is an important table. Try to keep this table because there are two NEMA questions on the training exam. Okay, my friends, and this is the procedure to calculate the signal loss. The total loss is the loss on the cable plus the loss on the junction. The loss in the cable is the loss in decibels per each 100 feet, depending on the type of cables, times the length of the cable, and all of this divided by 100. And the loss in the junction is basically the number of junctions times 0.5, and both measurements are in decibels. Okay, this is basically the theory that we have for antenna cables.